Hello everyone, today we're talking about Laws of Logarithms, section 4.3 in our book. First thing I want us to get down are the three laws of the logarithms, and then just some known values that we know logs are always going to be equal to. So whenever we take log base 10 of 1, going to be 0. Whenever we have log base m of the same value m, we're going to get a 1. Okay, so those are some known values. The first law is saying if I have log of a plus log of b, I can rewrite that as log of a times b. If I have log of a minus log of b, that just equals log of a divided by b. And if I have log of a raised to the n, I can pull that n out in front, so now it becomes a constant n times log of a. So we're going to be using these laws, manipulating them to get answers to the following example questions. Next, use the laws of logarithms to rewrite the expression so we no longer have any multiplication, any division, or any power, or any root as well. So in this case, we have x times y, and we also have raised to the 10th. So I'm going to rewrite this as log base 2 of x to the 10th plus log base 2 of y to the 10th, right? I'm just using the first law of logarithms to rewrite the multiplication. And the 10 is obviously distributed to both the x and the y because we're multiplying. And then I'm going to use the next law to bring that 10 out in front of both of them. So I'm going to use law 3. So 10 log base 2 of x plus 10 log base 2 of y. And we're done. I no longer have a logarithm of a product, a quotient. I no longer have any roots or any powers. So that's as far as I can go right now. Next, we're going to use to, again, write the logarithm with no products, quotient, roots, or powers. So, first thing I'm going to do here, I can see that I have log base 5 of x minus 1. So log base 5 of x minus 1, right? And that's raised to the 1/2. So raising a number to a fraction is the same as taking the same root of that number. So since this is a square root, raising it to the 1/2 is the same as a square root. So if we're taking a cube root, raising it to the 1/3 would be the same as taking the cube root. So I'm just going to rewrite my top portion with my power, my root. And since it's division, that's minus log base 5 of x plus 1 raised to the 1/2. So again, bring those 1/2s out front. And bring the 1/2 out front again. Now, you can see I've been careful here to make sure that my x plus 1, or my x minus 1 and my x plus 1 are in parentheses, because I don't want you to think I'm taking log base 5 of x, then subtracting 1. I'm taking log base 5 of x minus 1. And in here, x minus 1, x plus 1 is not a product, quotient, root, or power, so we're done. We've rewritten it without any products, quotient, roots, or power. And one more, just to give you another example, works the same thing with natural logs. So my numerator is natural log of 3 plus natural log of x squared. I can't have a product, so I've got rid of the product there. And then this is minus natural log of x plus 1 to the 10th. The minus takes care of the division. The plus here is the multiplication in the numerator. So now you go one step further, ln of 3. I can bring my 2 out front, and I can bring my 10 out front. Making sure I keep the x plus 1 in parentheses. And so I've rewritten this logarithm into separate logarithms with no products, quotients, roots, or powers. Now they want us to evaluate this expression. So first, and this is where our laws come into play to help us evaluate this expression. Our calculator can't do log base 2 of 112, right? And it can't do log base 2 of 7. And if you were to rewrite these, right, so you'd get 2 to the x equals 112 here, minus 2 to the x equals 7 here, right? And those values, they're not nice numbers, right? There's no nice, neat number that'll give me these values. So we're going to use the laws of logarithms to rewrite it. So since this is a minus, we're going to have a division. So I get log base 2 of 112 divided by 7. Right, so I've just rewritten, I've taken that, made it into a quotient. And I can simplify log base 2 of 16 because 112 divided by 7 is 16. And now I can rewrite it 2 raised to the what power? So this is, right, this is equal to some number. I'm trying to evaluate the expression, so it's equal to some number. So 2 raised to some value is 16, and that value happens to be 4. So if you try to do it straight from here without using our laws, there's no way we're going to get to a 4. But as you can see, real easy, by rewriting it using our laws, we can come to a value of x equals 4. Now they want us to take this expanded logarithm and write it in a single logarithm. So my first two, there's a plus in between my natural logs, so that must mean I have the product. So I have ln out in front, it's out in front of everything. Then I have my numerator is a plus b, a minus b. Okay, so that's my numerator because I'm adding these two natural logarithms, which means it's a product. The minus here means then I divide ln of c, and the 2 out in front means c must have been squared, right? Because that 2 is a power. So we're taking the ln of all of this. Be careful, because in past years, students will want to put ln with each of these terms. That's not how it works. When we write it as one single logarithm, one single natural log, I'm taking ln of all of that. That is all part of the natural log. And finally, use the change of base formula in a calculator to evaluate the logarithm correct to 6 decimal places. So, change of base formula. So, what we're going to do basically is we're going to break it up into log base 10s so we can evaluate this. So, right now we agree our calculator can't do this, but we can rewrite it with the change of base formula. So what that's going to look like, it's going to be log of 2.5 over log of 12. So the base of our original logarithm goes to our denominator. If you want to think, it was the bottom there, so it stays the bottom. That's kind of how I used to think about it. And obviously whatever we're taking the log of is then the numerator. So this is the change of base formula. Whatever the base was goes in your denominator. Whatever you were taking the log of is your numerator. And now you're just taking the plain old log of both of those, which our calculators can do. So you just type in log of 2.5 divided by log of 12. And you will get 0.36873. It wants the 6 decimal places. So if you tried to do this, calculator can't do it. But by using the change of base formula, we can go ahead and get it in a form where a calculator can solve it, and we can eventually get to the approximation to 6 decimal places of that log. So go ahead and try the examples that accompany this in the PowerPoint, and we'll talk about this in class tomorrow.